This is Van-Gelder Tutoring and welcome to Relative Mass Part 1. In this session we're going to cover relative atomic mass, relative isotopic mass, as well as some calculations. In chemistry, relative mass is used instead of actual mass when we're talking about the mass of atoms or molecules. This is because the mass of molecules is incredibly small. In Part 1, relative mass, we're going to look at relative atomic mass and relative isotopic mass. You do need to know the definitions for both. We'll start with the definitions. Relative atomic mass is described as the weighted mean mass of an atom of an element compared to 1/12 the mass of carbon-12, while relative isotopic mass is the mass of an atom of an isotope of an element compared to 1/12 of the mass of carbon-12. The comparison to carbon-12 is very important here, as the mass of an atom is so small, using conventional units such as grams or ounces wouldn't work, as the number would be small and impractical to work with. Instead, we know that carbon has a mass of 12, so we compare the mass of all other atoms or molecules to that of 1/12 of carbon-12. In terms of the definitions themselves, they're only slightly different. One looks at the weighted mean mass, which we'll come to shortly, while the other looks directly at the mass of an isotope. If you look at your periodic table, you'll notice that chlorine has a mass of 35.5. Chlorine isn't the only element on your periodic table to have a decimal in its mass. But of course, you can't have half of a proton or a neutron, and the mass of an electron is so small it could never account for the mass of 0.5. So where does this decimal come from? It comes from isotopes. Chlorine has two commonly occurring isotopes, which are chlorine-35 and chlorine-37. The mean of 35 and 37 is 36, however, but 75.5% of all chlorine is chlorine-35, while 24.5% of all chlorine is chlorine-37. So to simply use a number that's halfway between the two wouldn't be accurate, so we have to take into account the mass of each isotope as well as how much of that isotope there is, which is known as the abundance. This can be done mathematically with a fairly straightforward formula, and is something that you're expected to be able to do. Let's start with an easier example. Boron. So boron exists in two forms, boron-10 and boron-11, although boron-10 has an abundance of 80% while boron-11 has an abundance of 20%. We can calculate the relative atomic mass using the following formula. We multiply the mass of the first isotope by its abundance. We then multiply the mass of the second isotope by its abundance, and then we add these two numbers together. Then we divide by 100. In this case, we can start constructing a formula quite simply. We know the mass of isotope 1 is 10, while its abundance is 80. And the mass of isotope 2 is 11, and its abundance is 20. Then we add in the division by 100, hit equals, and we have our answer of 10.8. So let's try a slightly harder example, which is chlorine-35 and chlorine-37. So straight away we can start constructing our equation. We can see that chlorine has a mass of 35 and an abundance of 75.5. We then add in the second part, where chlorine has a mass of 37 and an abundance of 24.5, and then finally add in a division by 100. This will equal 35.49. Now in chemistry, in the mark scheme, it will always be specific to three significant figures. So if a question results in an answer that has a large number of decimals, or more than three numbers that aren't zero, we generally stick to three significant figures. However, some questions may specifically ask you to use a certain number of significant figures. So in this case, I've displayed both. And that concludes part 1. Thank you for watching. This is Van-Gelder Tutoring, and if you want to support the channel in a free way that is very helpful to me, please feel free to drop a like and a subscribe. See you in part 2.